And we're just gonna do a split-second tap on my mouse and fire this heliwatt laser at the planet. Holy moly. It is 200,000 degrees Celsius. It went from 300 degrees Celsius to 200,000 degrees Celsius in a split second. Hello, everybody, and welcome back to Universe Sandbox 2. We actually have a pretty big update that came out tonight, the night that I'm recording this, and it might come out the next day or maybe the day after that. But we have surface grids and lasers. Surface grids are here. There's a big update, adds new layers to the simulation, blah, 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 blah. The surface grids, like, I guess you can kind of map out the surface of a planet and you can analyze things about it. I mean, that's kind of cool. Maybe we'll check that out a little bit. But what I find more interesting is they added a giant laser to the game where you can just simply fire at the planet, maybe destroy it, and you can also kind of carve the surface a little bit. But I just kind of want to play around with this and see what we can do, what kind of destruction we can cause with it. So naturally, we're going to go to Earth. We're going to zoom in on there. Let's slow down time. Okay, until it's basically at a standstill. So here is the laser. Okay, so we have a wavelength, we have the radius of the laser. Oh, can we make the radius? Actually, no, let's just see what like the default stuff is. Oh, I just fired it. Okay, so we're just gonna take the default laser. I have to bring it up again. We're just gonna fire it at Earth, and we're going to see what happens. Let's just destroy Texas, all of Texas. Okay, that was a little bit. Hold it, and we can destroy all of Texas. Okay, and I can carve my name into the planet. Let's make this a little bit more powerful. Let's do double the power. All right. Oh god, and that Earth is moving. Z. Okay, and let's speed this up and see. Maybe this will stay on the planet once everything has cooled down. Although I think it's probably going to end up like spreading out like that. Yeah. Okay, so it seems like all of Africa is frozen over. It messed with the ice caps. We have this whole channel over here. Basically, the Bering Strait and the Arctic Ocean are just kind of creeping into. I don't even know how to explain what's happened here. The Earth is frozen over after firing a really hot laser at the planet. Let's make this laser more powerful. So right now the laser is currently set at 500 exawatts, which comes after petawatts, and then petawatts comes after terawatts, and then terawatts comes after gigawatts. So it goes mega, giga, tera, peta, exa, zeta, yoda. Every 3 zeros you have what's called a metric prefix, and I'm sure you've learned about that in science class. Some of you may not have learned past giga or tera, because you don't, quite frankly, need to know them unless you're working with really, really big numbers, and we're working with really, really big numbers here. But let's try and make a zeta-watt laser. 1 zeta-watt laser pointed at planet Earth of 650 nanometer wavelength, which would make the color red. Fire! Okay, that didn't really do much, actually. Although it definitely heated up a little bit quicker. Let's fire for a long time at the planet. And then maybe Earth's surface. Let's actually just close out of this and we can analyze Earth's surface, and maybe it'll just keep getting hotter and hotter and hotter. Average surface temperature is 181 degrees Celsius on average around the planet. And it's definitely going to get hotter and hotter and hotter and hotter. And I'm sure the Earth is just going to completely start going red as soon as we get to about 1,000 degrees Celsius. Yeah, everything's just starting to melt at this point. I can see it. I can see it around around the United States. Yep, now it's getting orange. Okay, well, that's pretty cool. So we basically just increase the internal temperature of the planet just by firing a laser at one spot for maybe an hour's worth of real time. Now, what happens if we increase this to 10 zeta-watts? It's obviously going to happen quicker, right? And it's going to start becoming white hot. Let's do that times 10, 100 zeta-watts. Okay. Oh, Jesus Christ. All right, let's do times 10, and we'll have what's called a yoda-watt. So there'll be 1 yoda-watt. I mean, Earth is already completely disintegrated. All right, well, let's start with Mercury. Mercury is a rock, and we'll just fire it at Mercury for a split second with a yottawatt laser. Just a split second. We just do it. You can do a quick click. Okay. So. Okay. Yeah, and that's 1 yottawatt that we did right there. Okay. Now let's take it a step further. We're gonna do 1,000 yottawatts, which would bring it to 10 to the 27 watts, basically. And I remember in high school when I was taking honors physics. It was in my honors physics class when I was in junior year. There was a petition going around somewhere around my area because this is a NorCal thing I'm about to explain. If you're familiar with the word hella, then that's hella cool, man. That's hella tight. It got known as a NorCal thing, I guess, at least in Northern California. And there was a petition to use the word hella as a metric prefix past yotta for 10 to the 27. So it would be giga, tera, peta, exa, zeta, yotta, then hella. So you would have a hellabyte, a hellameter, a hellawatt. So 1,000, what I'm saying is 1,000 yottawatts would be 1 HW or 1 hellawatt. And I'm gonna call this the hellawatt laser. Oh, Jesus Christ, that thing is a powerful laser. Okay, and we're gonna fire it at Venus. Just for a split second. We're actually gonna take this down to real time, or as close to real time. Okay, that's a little bit slower than real time. Give me real time. That's practically real time, just slightly slower than real time, which is, we're probably gonna need it. Okay, so I'm going to bring up the composition of Venus. So the average surface temperature of Venus is 345 degrees Celsius. And we're just gonna do a split second tap on my mouse and fire this hellawatt laser at the planet. Holy moly. It is 200,000 degrees Celsius. It went from 300 degrees Celsius to 200,000 degrees Celsius in a split second. Now, is the planet going to survive? The mass of less than 3,000 oceans, and it's shrinking, and it's damn hot, and I don't think it's going to be able to maintain its mass. This thing is going to shrink into a rock very quickly. Oh yeah. Now it's only the mass of 900 oceans and dropping. I want to see what happens like when it just turns into like a little it just became a pebble. Oh God, and it's gone. And I went into the milliseconds per second there. So yeah, in the span of maybe 30 seconds or so, all of Venus would completely vaporize if it was just like a split second click, less than a second of exposure to this laser. Let's try something on Mars. I want to mess with the wavelength of these lasers. So here's Mars. Let's do this again. So, I mean, I'm gonna think back to physics. From what my understanding is, you have a spectrum of visible light, and you can see it right here. Visible light. This is the spectrum. This is a longer wavelength, and it's illustrated by a number. Red has typically the longest wavelength in visible light, whereas violet has the shortest wavelength. And I believe when there's a shorter wavelength, it means there's more energy in that wavelength. It's a much more harsher and much more powerful ray of light. And the same could be said about radio waves, which are actually just the same thing as light. It's just a different frequency. It's just not part of the visible light spectrum. So I don't know if this is going to do something to the power of this laser. Like, is it going to compound it if I use a violet laser, or maybe it just ends up working out to be 1,000 yottawatts anyways. But I'm going to fire this at Mars. We're going to keep this in the milliseconds per second. Okay, and Mars is heating up, and it is at 1,000,000 degrees Celsius. From almost absolute, not absolute zero, but like minus 70 Celsius or something. I can't remember what it was. This is going, and what's the mass? The mass is at 440 oceans, and we're only in the milliseconds per second right now, so it's losing a whole ocean of mass in less than a second per second, or I don't know, man. Holy crap, all of this gas. This is the planet just vaporized, mid-vaporization. Mars doesn't even stand a chance to this thing. There is a cloud moving away from the planet. It's like the cloud already knows, like, gravity is not a thing here anymore. We're gone. But I could try this with non-visible light. Let's see here, just to, I don't know, in my head kind of confirm it. So let's increase the wavelength of this thing to infrared. It's technically, I guess, like an infrared laser, maybe. It's black, you can't see it. So infrared laser, it'll probably still heat up the planet because it's still energy you're firing at it. Average surface temperature is a minus 156 degrees Celsius. It is definitely getting hotter when I fire even a kilowatt infrared laser at it. Now let's go the opposite way. Let's go ultraviolet. And I guess it's going to be even more. But one thing I do notice is that with the infrared laser, it only heated up to about 5,000 degrees Celsius. Now, if we do an ultraviolet laser, oh, interesting. It's actually takes a lot more to heat up the planet. And I guess that makes sense because it's just a bigger planet. There's just a lot more mass to actually heat up. Let's go even longer. Although I did notice there was a lot more of a jump. Actually, there actually wasn't that much more of a jump. But yeah, it's actually showing the laser. So it's technically an ultraviolet laser. Let's get this to 1,000,000 degrees Celsius. Can it even get that high? This thing is just outgassing everything so quickly. It doesn't even know what to do. Oh, here we go. Even quicker, even quicker, even quicker. 7 seconds per second. Okay, and just watch the planet just burn up. All of this gas, it's like it has its own rocket fuel. Its mass is acting as a propellant to go through the solar system, and I'm wondering if it's actually changing the orbit at all. So we're sitting here at 313 Earths. Temperature is actually dropping, so Jupiter might actually be able to survive this if it could cool down quick enough, but I don't think it's going to because it already lost 2/3 of its mass. Still in the 330,000s in terms of temperature. But is the orbit changing at all? Can't really tell. I don't think it is, at least to a noticeable extent. That's crazy. And now we're at the mass of 45 Earths. Oh yeah, this thing's gonna get burnt out. And it's gone. Oh, it became a little pebble. That's so cute. Okay, we gotta bully Pluto. Let's see what happens. Oh god. With Pluto, you're such a smaller planet, a dwarf planet, not even a planet because you're just not classified as one anymore. You're looking pretty nice, Pluto, but I think I need to give you a baby laser. Let's give you a baby laser. Let's just give you a Yoda watt. 1 Yoda watt laser on Pluto. Just do it for a split second. Boop. It didn't even stand a chance. Although it was going at 3 hours per second. Oh, it's the poor thing. Poor thing. God, let's try and blow up the sun. Always wanted to say that. My supervillain alter ego. Let's just blow up the sun. All right, we're gonna go 1,000 Yoda watts. Let's see if we can do this for a while. Blow up the sun. Is anything changing? Surface temperature isn't even changing on the sun. I wonder if the lasers can even affect it in this game. Let's try to prove it. Okay, we're gonna go 10 times this and go 10,000, 10 kilowatt laser. Still not doing anything. Okay, 100,000. Yeah, it's 100 kilowatts. Now we're gonna go 10 to the 30. Oh my god. Yeah, you can't blow up the sun with this. That sucks. No, man. Okay, yeah. So it must be limited. It must be limited to. It has to be limited to just planets. And then once it reaches a star, it just doesn't affect stars, because I feel like you would cause the sun to go into supernova if you just forced that much energy into a star. Time to fire a laser up Uranus. Let's do a little baby laser. Let's do some preset ones. Let's see what that. Okay, so what's Athena 2017? Is this a hot laser? It's not doing anything. Okay, most powerful continuous laser. That doing anything? Not doing anything to Uranus. Uranus can take anything. Right there. Nope. Okay, it's just like a white laser. Medium is carbon. Or a preset interstellar propulsion laser. Oh, that's actually heating up Uranus. Really? Okay, let's just keep that going. Maybe we can make Uranus habitable with a single laser. And that's it. Just point this laser at Uranus and you can gradually heat up the planet, which is actually getting some diminishing returns. Oh, it's a 15 exawatt laser. That's why. Jesus Christ. Most powerful pulsed laser. Wait. Most powerful pulsed laser? You mean to tell me? You mean to tell me that this laser exists, or is that in sci-fi? So this is a research laser. This is Zeta watt laser. Oh my god. Now the Galactic Empire super laser is 2,500 yodawatts. Is this proven in research? Holy crap! That's actually more powerful than my my heliwatt laser. So the Death Star laser is now rated at 2.5 helawatts. So remember that. So if you want to say you learned anything from this video, you know, it's not 2,505 yodawatts. It is 2.505 helawatts. The Death Star laser. God, is there a Death Star like object at all? Death Star. There is no Death Star? It's probably copyright stuff. They probably can't put that in here. God damn it. God, what can we do to Yo, black holes. Hold on. New. Okay, we need to experiment with black holes and light bending. Ah, yes, let's go. Okay, Sagittarius A. Okay. Please, physics. I know you're a simulation. I know you're not perfect, Universe Sandbox. Please do not let me down with how light works and space-time and yippity-doo-dah. Okay, let's get a little bit of a smaller laser here. Fusion research laser. Okay. I'm not seeing any light bending, even when we get past the event horizon. No, nothing's happening to the black hole there. Oh, Jesus. Okay, let's just fire the Galactic Empire super laser into Sagittarius A. Can we destroy a black hole with a laser? Although we're in the hours per second, I feel like we need to be on a much larger scale here. Still nothing's happening to this. Let's see here. Is there, like, do I even get like temperature settings at all when I'm dealing with black holes? Let's just get out of this. I don't want to deal with you. Okay. So yeah, so the temperature of Sagittarius A is absolute 0, basically. So that even the Empire's laser has no effect on a black hole. But is there a value where there might actually be an effect? First of all, this is going to be ultraviolet, or let's make it violet instead. Let's make it so you can at least see it. And let's increase it to 25,000 helawatts. Can we crack this to go to minus 272 degrees Celsius? There has to be some warmth within that black hole. Come on. All right, even hotter. Come on. You mean to tell me a black hole is truly a black hole and you don't know where this is going and we're probably destroying entire universes on the other side? It's probably acting just like stars. You probably can't do anything to black holes. But God, I really want something where I want them to put in some kind of update where if you fired a laser past the black hole, it would actually curve around and you can change the direction of the laser. I would love to play around with like some black hole system where there's a bunch of black holes just orbiting each other and you're firing lasers and you have them curving in all sorts of directions. That would be such a cool experiment, but that could just be an engine thing. You know, it may not even be feasible. Yes, I am talking directly to you developers. I'm acknowledging that maybe not everything is possible, but I'm letting you know what would be really cool if it is possible. Okay, so now it's showing the surface of the planet. And so I wonder if I can, it's showing no liquid CO2 depth data for Earth. I wonder if I can use the laser just on the surface right here. Okay, I don't want a yodawatt laser anymore. Let's go gigawatts. Let's do 1.21 gigawatts, even though it's probably not going to do anything. Yeah, I don't really know what to do much with the surface grids because the elevation stuff wasn't changing, but it's cool just to have more data to look at so we can do more testing on a planetary scale. But I'm going to try one more thing. I want to bring back our big laser. Let's just get the Galactic Empire super laser. Now let's make the radius super small. 1.2 kilometers, 1.2 meters, 12 meters. Okay, 1 meter thickness. And now it's like reduced to petawatts. Jesus Christ. No. We're going back to yodawatts. We're going to go to 2,500 yodawatts with a 1.2 meter radius. So it's going to be such a fine laser in the grand scheme of things. And I want to see how this affects Earth in pretty much real time. Real time. Give me real time. That's practical real time. Okay. Here we go. Oh, just a small click like that. Did that do anything? Okay. So it actually definitely seems like, ooh, God. I feel like I see something's happening right there. What? Did that do anything? 13 degrees Celsius? So a powerful laser like that touching the planet. Maybe we need some more time for the things to speed up here. Holy crap, Earth can actually survive that when you keep the radius pretty small. 2,500 yodawatts? Has no effect? Holy crap. What if we increase the power to 10 times? Still no effect. That might just be a programming thing. I feel like this would not be accurate. That much power even in a small point like that? Let's go 2 times. 2 times the thickness. No? 2 times that thickness. Oh yeah, we're melting some stuff now. Okay. Okay. Oh, that's cool. We can choose to melt some of the snow. We can make our own snow angel. We can carve. Let's see here. In the middle of... What is this? Is this Siberia right here? SOS. Just melt the snow. Some news story comes out. It's like, snow has mysteriously melted in a strange fashion in Siberia. There we go. The Russians say help. Oh my God, it's a SOS for the aliens. Please get us off this planet. Now let's see what happens over the long term here, using a powerful laser like that. So when you have a 5 meter wide Death Star laser, basically, it can melt snow at best. You can definitely melt the ice caps with it very, very slowly. Actually, you probably can't even do that. You can, let's go 10 times. Let's go 49 meters. Will that do a whole lot? Okay. Yeah, you're starting to create some damage where it's like some nukes going off. That's probably like what it is. It's like a really big nuke that just went off. That looks like, you know, a few megatons right there. I think this is Paris right here. So we fire that. Yeah, that's like a few megatons, I would say. A few megaton nuclear bomb going off. A 50 meter wide galactic laser. Now let's go 10 times. And then bad things start happening, right? Actually, not much really changes even when you go from 50 meters to 500 meters. I mean, we destroyed all of Europe in a span of a few seconds. Now let's go 4.9 kilometers. Now bad things are happening. Now we can vaporize the planet. Things are starting to get pretty hot pretty quickly. 49 kilometers. Oh yeah. Now we will vaporize the planet. Oh yeah. Then boom. I don't think you can blow up black holes. You can't blow up stars. But you can have a lot of fun blowing up planets and carving messages in them. I don't know. Fun little feature, I would say, but that's probably going to do it for me for now. Maybe we'll come back to messing with this some more if I could think of some more stuff. But yeah, until then, I hope you guys enjoyed, and I'll see you all later. Explosions. Explosions. Ooh, I was actually getting a little bit of lag right there, but it's not too bad. Oh, it's beautiful. Beautifully crackly, but I am not seeing